this video, we're going to talk about complex zeros of a polynomial function. First, I'm going to give a few theorems, and then we're going to do two examples. In the next video, we'll talk about how to find zeros of a polynomial function using these theorems and these ideas. Okay, so let's go ahead and get started with the theorems. First is the fundamental theorem of algebra, which that basically just says that if you have a polynomial function and the coefficients are complex numbers. A complex number, remember, is a real plus an imaginary. If the imaginary part's not there, then complex number can also be a real number. So complex or real number as the coefficients, then the polynomial has at least one zero. Okay, so that's the first thing. You must believe that there's at least one zero for every polynomial function. All right, let's go on to another theorem. So the number of zeros theorem. Okay, so the first one says that there is at least one zero, and so this theorem says that any polynomial of degree n has exactly n zeros. Okay, provided that a zero of multiplicity n is counted twice. So, for example, if you had a polynomial that factored out like this, x minus 2 squared. So x equals 2 is a zero, but you'd have to count it twice because it has multiplicity 2 because it's squared. Okay, so this would be a polynomial of degree 2 having exactly 2 zeros. Multiplicity, this one's being counted twice. So we're going to use this theorem a lot. All right, let's do one more theorem. Okay, the last theorem is the conjugate pairs theorem, which says that if a polynomial, if p of x is a polynomial whose coefficients are real numbers, okay, so now the coefficients are real numbers, and z is a complex number, if z is a zero of p, the polynomial, then its conjugate is also a zero of the polynomial. Okay? So we'll go ahead and start doing some examples. We're going to be using this theorem a lot too. Alright, so the first example, we have a polynomial, p of x is in degree 4 with real coefficients, has the zeros negative I and 2 minus I. Find the remaining zeros. Well, we know that in the end, we should have 4 zeros due to the number of zeros theorem. Okay, so we should have 4 zeros. Right now we have 2. 2 were given to us, negative I and 2 minus I. Okay, due to the conjugate pairs theorem, the conjugate of I is positive I. Remember, if z equals a plus bi, and then the conjugate is a minus bi. So flip the sign that's in front of the I. Okay, so the conjugate's I, and then for this one, the conjugate would then be, instead of minus, be plus. Okay, so what are your zeros? Negative I, 2 minus I, 2 plus I. And that would be your answer. Okay, let's do one more example. In this example, it says the polynomial p of x with real coefficients has degree 4 and leading coefficient negative 3 and zeros 2i and negative I minus 1. So now it's asking us to find p of x. So before we can find p of x, we need to find all of the zeros. They only gave us 2. So there's 2 more because it's of degree 4. So the corresponding pair for 2i would be negative 2i. And then I'm going to rewrite this one as negative 1 minus I, just because we're used to seeing complex numbers written as, with the imaginary part on the end. Okay, so then the conjugate for this would be negative 1 plus I. Okay, so there are my zeros. Let's list them out. 2i, negative 2i, negative 1 minus I, and negative 1 plus I. Okay, those are my zeros. So now if I'm trying to make my polynomial, all right, the leading coefficient is -3, so I'm going to put that out front. And then I'm going to have x. So if I subtract off the zeros, so this validates that 2i is a 0. If I say x minus 2i, then that validates that, so this cancels and would make a 0, right? Then if I say x plus 2i, that kind of validates that this is a 0, right? If you were to plug in -2i, this would cancel and the whole thing would go to 0. Then x minus -i, or -1 minus I, okay? And then x minus -1 plus I. All right, so now I just need to, do some algebra and make this neater looking, and they make it look like a polynomial with only real coefficients. Okay, so I'm gonna leave the -3 out there, and I'm gonna FOIL this, these first two here. So I'm gonna do x times x is x squared minus 2ix, and then plus 2ix, and then minus, so now the last terms are multiplying these two, so that's -2 times 2, which is -4, and then I times I, which is -1. Okay, that times, let's do the same thing. I'm going to FOIL over here, so I'll have x squared minus, so I'm going to take, so first times the inner, so this one times that one. So that would be x -1 minus I. And then, so first, inner, outer, okay. So I'm running out of room, so I'm going to write that down here. Minus x plus I. And then the last two terms, okay. Since these last two terms are conjugates of each other, I can just do a squared plus b squared, okay? So that's what happens when you multiply conjugates. So a squared, so it's a is -1, so 1 squared is 1, and b is also 1, so b squared is also 1, so you end up having a squared plus b squared is just equal to 2, so plus 2. All right, let's do a little bit of cleaning up here. These two terms cancel, and so you have x squared plus 4. And then over here, let's see, I have x squared. Let me go ahead and distribute this negative x here. So I'll have plus x, because it's times that -1. And then negative x plus, so negative xi. Okay, that's me distributing this in. So that'll be negative x times -1 is plus x, negative x times -I, which is plus ix, or xi. Okay, same thing down here, so distribute, so that'd be plus x, and then minus xi, plus 2. These two now cancel. Okay, so I'm left with -3 x squared plus 4, x squared plus, there's two x's here, 2x plus 2. Okay, so now I just need to, multiply this by this. So to do that, I'm going to multiply everything by x squared. So I'll have x to the 4th plus 2x to the 3rd plus 2x squared. Multiply everything by 4. So plus 4x squared plus 8x plus 8. Okay, -3. So this now is going to be x, let's see, I need to combine like terms. So x to the 4th plus 2x to the 3rd plus, let's see, I have 2 of these terms, so that's going to make 6x squared plus 8x plus 8. Okay, so now the very last step is to distribute that -3, and then I'll be good to go. So I'll have 3, really I've run out of room. Okay, so let me go ahead, I'll just try. So I'll have 3x to the 4th 3x to the fourth plus 6x to the third. Oh, I'm distributing a negative 3, so the sign will change. Instead of it being plus, it'll be minus. And then minus 3 times 6 is 18, x squared. And then that plus will become a minus, and this will be negative 3 times 8, which is 24, x, and then negative 24. Okay, and then that will be my answer.